Alright, hey guys, I know that we decided that we were going to talk about deductive reasoning, but I've actually decided to make a quick change and we're going to start talking about logic. And then once we finish logic, we'll move into deductive reasoning. You'll see why when we get to deductive reasoning. Alright, so first off, in logic, we have statements and conditional statements, okay? A statement is a sentence that's either true or false, but it can't be both. So taking a look at our first two examples, we have that Atlanta is the capital of Georgia. You guys know that to be true, so this is a true statement. Alright, and also the Atlanta Falcons are a professional basketball team. Well, that's false. They're a professional football team. So that is a false statement, okay? Right below, you'll see that these are not statements. There's a couple reasons why. The first one is a question. What's your favorite music video? The answer is not true or false, so it's not a statement. Alright, turn up the volume so I can hear this song is a command. That is not a true or false statement. Now, a conditional statement is a little different because it starts with the word if, like if I go to the store, comma, then I will buy this shirt. Okay, that is a difference between a statement and a conditional statement. Alright, so we're going to use some, if you've ever read Alice in Wonderland, this is the Mad Hatter Tea Party. They say some kind of crazy things, but Lewis Carroll was actually very good at math, and he included logic in his book, okay? So if I see what I eat has the same meaning as the conditional statement. If I eat a thing, then I see it. So taking a look at letter A, we need to change this statement into a conditional statement. The first statement says, I like what I get. So you would change it to, if I get it, then I like it. For B, I breathe when I sleep. So if I sleep, then I breathe. Okay? Now, there are two parts of a conditional statement, and the first part is called the hypothesis. It always follows the word if. So if we go back to the previous page, if I sleep, the hypothesis here would be I sleep. Notice it does not include the word if. Okay? Does not include the word if. That is not part of the hypothesis. This is very important. Now, with conclusion, it always follows the word then, but again, does not include the word then. So going back to our previous statement, I breathe would then be my conclusion. Alright, so let's do some practice. If I eat a thing, then I see the thing. The hypothesis here would be I eat a thing. Okay? And then the conclusion here would be I see the thing. So you can do what I'm doing where you underline it, okay? Be careful not to include the word if there, my bad. And underline it or circle it as your hypothesis or conclusion, or you can also write it in the blank spaces provided. Alright, so going back to the second one, I see a thing is my hypothesis, while I eat a thing is my conclusion. Careful to make sure that what follows the word then is your conclusion. Even if the sentence is all over jumbled around, it's the words that follow if, or the hypotenuse, or excuse me, the hypothesis, and then the words that follow then are the conclusion. Oh, so here's a little fun tidbit for my life. Remember that occasionally I throw out a pop quiz and I ask you something interesting about last night's video. So as you can see here, this is my wonderful cat, Ben Kenobi. He is one of two cats that I have, and his birthday is May 4th. So any of you Star Wars fans out there know that May 4th is May the 4th be with you day, and he is named Ben Kenobi after old Ben Kenobi in the older episodes of Star Wars. So that's him on the right. This is him right here as a little baby. And this is him as he was a couple weeks ago. So he's all grown up, about a year old now. Alright, so let's get back to business. Here we can say that a conditional is true or false by a couple of reasonings. First off, okay, when I say a conditional statement is true, it means that when the hypothesis is true, the conclusion must also be true. Okay, so let's give an example. So let's say the example would be, if I'm in Miss Norton's class, then I am doing math. If you're in my class, you are doing math. So that is a true conditional statement. So to say that a conditional statement is false means that while the hypothesis is true, the conclusion is therefore false. So you could say that, if it is Monday, then I am in school. Well, you have MLK Day, you have the summer break, September break, so that would be a conditional statement that is false. So notice that when I proved that last conditional statement, I provided you with a counterexample, just like what we did in inductive reasoning. Providing a counterexample will prove that it's false, and you only need one example to prove the statement false. Alright, so let's do some counterexamples. Here is a statement. If the product of two numbers is even, then the two numbers must be even. I'm telling you, show that it's false by a counterexample. Now, on some other problems, I may say, is this a true statement, or is it a false statement? If it's false, provide a counterexample. So I'm not going to tell you, you have to figure it out. Alright, so what we're saying here is that an even number times an even number, remember product means multiplication, is an even number. Well, I can say, the product of any two numbers, not two even numbers, Okay, so that if the product of two numbers is even, then the two numbers must be even. Okay, so let's say, here's the product of two numbers, and it's even, 10. I can do 5 times 2 to get 10. Notice that it says if the product of two numbers is even, so this is the product being even, then the two numbers must be even. Okay, notice that 5 is not even, it's odd. So this right here, 5 times 2 is 10, is my counterexample. Alright, now, we need to talk about symbolic notation, okay? Notice that I have P and Q here. This part right here is called what from our previous slides? It's the hypothesis. While this one is the conclusion. So I'm throwing in a few new letters for you guys, but it's important because we're talking about certain notations. P arrow Q is actually read P implies Q, meaning that if P, then Q. P being my hypothesis and Q being the conclusion. Now occasionally we're going to switch things up. For example, if Q, then P. So no longer is it if I eat a thing, then I see it. It's now if I see it, then I eat it. We have switched the hypothesis and the conclusion, and we call this the converse. The way I remember is that P and Q switch places, and when I think of converse, I think of awesome shoes, right? So these guys are rocking an awesome pair of Converse. Okay, little bow for their laces. Okay, and Converse are used for walking, and they switched places. So, kind of a dorky way to remember, but it helps you all the same. Alright, so before we get into the last two types, we need to talk about negation. Okay, negation is this symbol here, like the squiggle P. It means not P. Okay, so I said if it rains, the opposite of that would be if it is not raining or if it does not rain. Okay, so those are a couple of examples. Now, if I negate my conclusion and my hypothesis, we call this the inverse. So, if not P implies not Q. If not P, then not Q. Okay, that is inverse. And the last one is contrapositive. It will switch places like the converse and negate like the inverse. So it's a long name, so it does twice the work. Okay, if not Q, then not P. So not Q implies not P. Alright, so let's do some examples of this. Here's a statement that says, if I get an A in math, then I will get my driver's license. First off, P is I get an A in math. Do you see that I did not include if? I will get my driver's license is Q. Okay, notice I did not include then. So the converse is Q implies P. Oops, don't know what letter that is. So it will be if I get my driver's license, then I got an A in math. Okay, the negation would be not P and not Q. Okay, so not P is that I do not get an A in math, while not Q is I did not get my driver's license. Alright, so let's try the inverse. Inverse is not P implies not Q. And then the contrapositive is not Q implies not P. So give those a try. Pause. Alright, so take a minute, check your answers, see how you did. That's the bell, and that's all we have for today, guys. So this is Logic Day 1. Tomorrow we will start Logic Day 2. And as the bell says, that is the end.